Today we're talking about dirt. So what do you think of when you think of dirt? Do you think of going outside? Do you see the dust fly all over your car as you go past? You see dirt in the fields. You see dirt on the ground when you dig up a hole. But I want to tell you like the different types of soil. So soil is of course is the loose particles of broken rock and decaying organic material. So if it's just rock, it's not soil. It has to have organic material in it in order for it to be soil. Soil is what helps things grow. There's a cool, if you watch the Martian, the movie The Martian, he actually does a whole thing on soil because technically the dirt on Mars is not soil because it doesn't have any organic material. So he creates organic soil on Mars during his time. So it's actually a pretty cool video. You should go watch The Martian if you get a chance to. It's pretty fun to watch. So it's found almost everywhere on Earth, including the deserts. Deserts still have soil because they still have organic material in it. And you'll see the result of chemical and mechanical weathering over time, biological activity over time, shows the different types of soil. So our first type of soil is residual soil. So this is soil located above the parent material, so something that's on top. So Kentucky bluegrass soil. This is what Kentucky bluegrass will actually grow better on. Uh, if you look at transported soil, it is something that is moved from one location to a different location. So say I take soil planting soil. If you use the planting soil in a plant and you transplant it and put it into your yard, so for instance, if I go buy a bush, it's going to be in some sort of soil. It is already in transported soil and is now being placed into my yard. So now I'll mix with the parent material in my yard. So agents of erosion, such as wind, water, glaciers, move soil. Also, human transplant. So wind is the big one. So that's where we see topsoil. So if you go through American history, we have this thing called the Dust Bowl. So the Dust Bowl actually blew topsoil from the west all over the entire United States. You can see it going from Oregon all the way to New York City. You can see pictures of the Dust Bowl in New York City during that time. So that's your transplanted soil. So in glaciers, of course, we talked about how when we talked about Pangea, we talked about how there's different glacial movement that shows different types of soil in different places. So this is another way that Alfred Wegener was right with Pangea. So in general, the process of soil formation is a long period of time. So to form new soil, it takes 100 years per centimeter. So it takes a long time to have that new soil take place. So erosion is a long process. It is not a short process. So if you look at, we're going to have a water table that you get to see and answer some questions about. That'll show you a model of what happens over long periods of time with water. There's actually another cool one that I just saw recently that was showing a river breaching into the ocean in India, and it was a long period of time, but it was really cool. It showed erosion in real life. Soils on slopes tend to be thin, coarse, and infertile because of the slopes. I mean, think about it. If you see a slope, seeds will roll just like rocks roll, just like balls roll, just like humans roll if they fall down. So it's much less likely to have a plant on a slope than you would have a plant in a valley. So that's why when we go look at the Rockies, there are more plants and animals in the valleys than there are in the peaks of the mountains because those mountains are very sloped and less fertile. That doesn't mean there aren't anything that doesn't mean there's not anything growing in it, but it means that it is less fertile, and so it's much harder for plants to grow. So there's less soil in those areas. South-facing slopes have thicker soils due to increased vegetation. So think about in the northern hemisphere, this is in the northern hemisphere anyways, we face south-facing slopes get more sunlight than north-facing slopes. It's just the way that, so if you have increased vegetation, it's going to create more soil because you have more biological components being put into it. Soil's appearance, rate of formation, and productivity are determined by the extent of the climate. So if you look at a rainforest, you're going to have a much darker, thicker, mud-like soil because of the amount of rain and the amount of vegetation there. If you look at the soil in a desert or in a dry grassland, it's going to be much lighter, much more coarse because of the lack of rain, the lack of vegetation. So if you don't have the biological component and you don't have rain, these will have a great effect on the soil's composition or the soil's appearance. Soil's composition and climate develop are the main reason for their color. So the color and composition are going to show what it is. So like I said, in a desert, it's going to be much lighter than somewhere like a rainforest or a forest where it's going to be a lot more rain, a lot more vegetation. And that is all for today. So go ahead and watch how erosion works and watch how soil works in erosion. Watch the water table, answer the questions that go with it, and that's your assignment for today.